Hi guys. In this video, we're starting Unit 7, Section 1, and we're going to talk about rational exponents and how it goes back and forth between the rational exponents and the radicals. Okay, so when we have a root, that number right there, is called the index. That number, well, the root is called a radical, and then that number, or sometimes it's a letter, under the root or under the radical is called the radicand. Sometimes when you don't have a number right there for n, when you don't have anything, the default is assumed to be 2. That's why we usually say, oh, square root. It's when we don't have that number or a different number right there on the root. So if no index, then it's assumed that it's a 2. That means the square or the square root. So when n, or the index, is an even number, okay? And a, the radicand, is an even, and a is a negative number, then there's no real roots because you're taking the square root, for example, of a negative number. And we know you will have an imaginary solution for that. So when a equals 0, then you're going to evaluate that. Then you're going to have the square root of 0 is 0, or the fourth root of 0 is also 0. So you're going to have one real root there. Now, if a is positive, then you're going to have 2 real roots like you would normally. Now, if the index is odd, 3, a 5, a 7, then a could be negative, or the radicand could be negative, and then you're still getting a 1 real root. And we're going to look at some examples, and it's going to make more sense there. So when a is 0, when the radicand is 0, you're going to have 1 real root, which is going to be 0. And then when a is positive, you're also getting still only 1 real root. Let's see how that works. Oh, we need to know how to simplify radicals. So that doesn't go away, guys. Sorry. When we don't have an index, the default is 2. So square root of 16 is just 4. But why is it 4? I know the index is 4. So when the index and the exponent match, they simplify, leaving me with only 4. Okay, how does that work? I have cube root of 27. I know 27 is 3 cubed. So the index and the exponent simplify down to just 3. 3 is the answer right there. Well, I put all the indexes right there, but this 3, this is the answer, this is the index. So when the index is 5, we're going to make groups, air quote right there, groups of 5. But I know 32 is 2 to the 5th power. 2 times 2 times 2 times 2 times 2 is 32. So when the index and the exponent, they're the same, they simplify down to 2. So 2 is the answer. We also already knew the square root of negative 144 would be imaginary because we're taking the square root of a negative number, and that's going to give me an imaginary 12 because the square root of 44 is 12 and the square root of negative 1 is just I. So no imaginary roots there, just 12i. No real root. That's what I meant. You know, yeah. Here I have the index is 4. The index is 4 right there. So to get 81, it's 3 to the 4th power. Index and exponents are the same. They simplify down to 3. Now, this negative is this negative. That doesn't go away. That doesn't disappear. I know that 1 to the 4th power is 4. In this case, they both simplify. Index and exponents are the same. That simplifies down to 1. This negative is this negative. Same thing here. This negative is this negative. Square root of 121 is 11. This is a perfect square. Cube root of negative 125. So split up that negative 1 right there, because I know 125 times negative 1 is negative 125. So I can split them up like that. And I know cube root of a negative number is -1. And I know it, I can just rewrite 5 cubed to get 125. And at this point, the index and the exponents are the same. They simplify down to 5. And then -1 times 5 is -5. So on page 2, we're going to go back and forth between the rational on the exponent to the radical. Notice that the numerator is going to be your exponent. Your denominator is going to be your index. Sometimes it makes sense when the parentheses are right there. Sometimes your exponent is right there under the radical. It doesn't matter, it means the same thing. Sometimes it's just easier, depending on what you have, to simplify it that way. Off we go. So 1/2, again, the numerator is going to be your exponent. The denominator is going to be your index. And I know when there's no index, that's the default. That's assumed to be square root. And this just looks funny. You don't put the 2 on the radical to say, oh, square root of 3. No, you don't put anything. The next one, we're going to go from the radical to the rational exponent. So invisible exponent right there. So 1 is the numerator. The index is the denominator on your exponent. Okay? So, and then we're going to evaluate. It's just hard to evaluate here, but it makes more sense if I just rewrite, because I know 3 cubed is 27, and I know the index and the exponent simplified because they're the same. So that simplifies down to 3. On the next one, we're going to rewrite. The numerator is the exponent. The denominator is the index. The base is always the base 7 with the radicand. So 7 cubed is 343, fourth root of 343. Numerator is the exponent. Denominator is the index. 8 squared is 64. And then you rewrite 64 as 4 cubed. Index and exponents are the same. That simplifies down to 4. This one is simple. There's not much you can do to simplify here. You're just rewriting. There's an invisible 1 on the exponent there. The exponent is the numerator. The index is the denominator on the exponent. Okay, so the next one, we rewrote it first with the invisible 1 on the exponent, and that's your now numerator from your rational exponent right there. Then 8 cubed is 512. Numerator, index and exponents are the same. That simplifies down to 8. This is pretty easy if you can figure it out that this means square root, because we have an invisible 1 right there on the exponent. And you also have the invisible 2 right there for the index. So square root of 121, easy, that's a perfect square, that's 11. Numerator is the exponent, denominator is the index. But notice that here it doesn't simplify from the get-go. I have to rewrite it to somehow, some way that's going to benefit me. I know if the index and the exponents are the same, they'll be able to simplify. But here, if I have 3 right here, I need a 2 there, because if I multiply, I add the exponents. So 3 plus 2 will give me 5. This one, index and exponent, simplify down to 2. That's this 2 right there. And then 2 squared is 4. And there's nothing I can do to simplify that cube root of 4, because this is not square root of 4, it's cube root of 4. Next one I have 81 to the power of 1/2. Invisible 1 here, invisible 2 there. So square root of 81, easy 9. 343 is a perfect cube, actually. And you'll get used to the perfect cubes that come up often. So rewrite this just because it's part of the process. But 7 cubed is 343. Index and exponents are the same. They simplify down to 7. Bam. We saw this one from over here that is not fully the same, but it's partially. Here I have cube root of 64 because I have the numerator is 1. That's my exponent right there. And I know 4 cubed is 64, so I rewrote it this way. And at this point, the index and exponents are the same. That simplifies down to 4. 216 is also a perfect cube. So cube root of 216, I can rewrite 216 as 6 cubed. And then index, exponent are the same. They simplify down to 6. Here, square root of 36 is 6, but this is just part of the process to rewrite this as a rational exponent, and we did just that. Same thing right here, square root of 100 is 10. Why is it square root? We already know that. All right, let's get going. Now this one, I had to rewrite this and break it down. So I know 8 times 1,000 is 8,000. I also know that 2 cubed is 8. And I also know that 10 cubed is 1,000. The goal here was to write both of them with the same index as the exponent, and we did. They both simplify down to 2 times 10, which is 20. And then here, lastly, I just rewrote this with a rational exponent. And this one I marked off because we did that very same one right there. It's the same question. I will record another video for pages 3 and 4.